Welcome to the deep dive. Today we're jumping straight into something really fascinating, agentic AI. Specifically, what makes some systems truly superior? Not just functional, but the ones really pushing the envelope. We've got this fantastic analysis you shared, digging deep into those differentiators. So our mission today, let's unpack it, pull out the core ideas, and help you get a quick handle on what sets the best systems apart. It's about the why, not just definitions.
Exactly. And this source, it lays out a pretty detailed framework. So yeah, our goal is to kind of synthesize all that complexity into some clear insights, really highlighting the key pillars of what makes these systems stand out.
Okay, great. So let's start with the basics, maybe the evolution. We've seen AI go from like simple reactive stuff to generative models, but the source calls agentic AI a significant conceptual leap. What's the big jump there?
Well, think about traditional AI agents first, like your email filter or maybe a calendar tool. They're usually single things, right? Built for one specific job. They work on their own, mostly, once you set them up. But they're kind of limited. Throw something really unexpected at them and they struggle, they react. But adapting to serious complexity, not so much.
Right. Limited scope. So agentic AI systems. Source says profound paradigm shift. That sounds big.
It really is. And the core idea, the thing that comes up again and again in the analysis, is the shift to multi-agent collaboration. Instead of one big brain, you've got a team of agents, often specialized ones, working together.
A team. Okay.
And that teamwork unlocks some really fundamental stuff. Dynamic task decomposition, breaking down huge problems, persistent memory, they actually remember things, learn over time, and orchestrated autonomy. There's like a conductor making sure they all play together nicely towards the main goal, not just doing their own thing.
So that multi-agent thing is really the cornerstone of being superior.
Yeah, I think the analysis makes a strong case for that. It enables specialization agents get really good at their niche tasks. You get synergy, where the team effort is way more than individual parts. And, crucially, robustness.
Robustness. How so?
Well, if one agent hits a snag or fails, the others can often adapt or compensate. It's not a single point of failure. Plus, it scales much better. You can add more agents for bigger problems. It's like building a super specialized, coordinated expert team. Lets you tackle problems way beyond what a single AI could handle.
That team concept really sticks. The analysis contrasts this, right? Like narrow versus complex tasks, single versus multi-agent, basic memory versus persistent. You can see straight away how just changing the architecture opens up way more complex stuff. Research automation, medical decision support, much bigger than a simple chatbot.
Exactly. And when you look at those differences laid out like that, for you, listening, what distinction really jumps out as the biggest leap? For me, personally, it's absolutely that jump to multi-agent collaboration and that orchestration layer. It feels like it fundamentally changes the game in terms of potential scale and complexity.
Yeah, I agree. That team idea feels revolutionary. Okay, so you've got the team, but how do they actually think? How do they plan and reason? The source gets into that quite a bit.
Right. Planning isn't just following a simple checklist. The analysis highlights a couple of main styles. One is more iterative, kind of reactive. Think frameworks like React. That's where an agent uses, say, an LLM to reason about something.
Okay.
Then it acts based on that reasoning, sees what happens, observes the result, and then thinks again based on that new information. It's this think, act, observe, repeat cycle.
Like learning as you go.
Exactly. It's fantastic for situations that are constantly changing, unpredictable. The agent keeps correcting itself based on what's happening right now, like an improv actor reacting moment to moment. And you often get this chain of thought reasoning, which makes it a bit more transparent,
Okay, so React is the improv approach. What's the other style mentioned? Agentic planning?
Yeah, that's more the strategist, the plan then act method. Here, the system does a lot of thinking up front, analyzes the goal, breaks it down into detailed steps, tries to predict problems before it even starts doing anything.
Like drawing up a detailed blueprint.
Precisely. It's great for structured tasks where you know the steps, maybe complex projects or strategy games where efficiency and knowing the path matter a lot. But the source suggests, and this is key, that the really superior systems often blend these approaches. They use hybrid planning.
Hybrid. Combining the two.
Kind of, yeah. Balancing that strategic long-term view from plan then act with the ability to react and adapt tactically like React. So they have a clear goal but can still adjust on the fly. Super important for complex business processes, for instance. And to handle really complex plans within that, they might use hierarchical planning.
Hierarchical. like levels.
Exactly. Breaking big goals down into sub-goals, then sub-sub-goals, like outlining an essay before you write it. It's a way to manage complexity, helps with scaling. It really embodies that dynamic task decomposition idea. And if there's uncertainty, incomplete information. They might use probabilistic planning techniques, thinking in terms of likelihoods, beliefs about the world. This helps them make more nuanced, maybe more human-like decisions and stay focused on the goal even when things aren't perfectly clear.
Interesting. So it's about having a whole toolkit of planning strategies. And, okay, they have a plan, but things change. The source talks a lot about dynamic learning and adaptability. Superior AI isn't static, right?
Absolutely not. That's a huge point. Superior systems are designed to evolve. Continuous learning is vital. I need to be able to learn from new data, new experiences, without forgetting everything they knew before. Lifelong learning, basically. Keeps them effective as the world changes, fights that model drift problem.
Drift, where performance degrades over time.
Yeah, exactly. Continuous learning helps combat that. Then there's reinforcement learning, RL. That's learning by trial and error, trying things, getting feedback rewards or penalties, and figuring out the best actions over time. This lets them discover really smart strategies on their own, sometimes things humans wouldn't have thought of. Deep RL, like AlphaGo mastering Go, is a powerful example.
And multi-agent RL, is that the team learning together?
You got it. How multiple agents interacting can learn to coordinate and achieve collective goals, just through interaction and shared feedback. Huge potential for things like traffic control or robotic teams. And another fascinating capability the source mentions is few-shot learning, FSL.
Few-shot, meaning not much data.
Exactly. The ability to learn a new task or adapt to a new situation with just a tiny amount of data, maybe only like 5 examples or even fewer. It leverages all its prior knowledge to generalize super quickly, makes the AI much more agile, faster to deploy in new scenarios, potentially more cost-effective too.
Wow. And underpinning a lot of this, the large language model, the LLM, right? It's sort of the brain.
It often acts as the cognitive engine, yeah.
Yep.
It provides that deep understanding of language, context, allows for the sophisticated reasoning needed to interpret complex requests or situations. When you pair a powerful LLM with these agent frameworks we're discussing, it becomes much more than just a chatbot. It's really a potent decision-making core, tying together the planning, learning, memory, all of it.
Okay, so they're smart, they learn, but they also need to be reliable and efficient. Right? Robustness, scalability, resource optimization. The source lists these as key pillars too.
Definitely. And that multi-agent architecture we keep coming back to. It helps here too. Specialization helps. But also, remember the fault tolerance. If one agent has an issue, the whole system doesn't necessarily crash. That's robustness.
Ah, right. Built-in backup, kind of.
Sort of, yeah. And distributing the work across many agents inherently makes it more scalable. You can often just add more agents to handle bigger loads or more complex tasks without your costs exploding linearly. And resource management. That's about being smart with computing power, memory, etc. The analysis points to agentic RG systems as an example.
Agentic RA, retrieval augmented generation, but with agents.
Exactly. They use clever tricks like semantic caching, remembering the meaning of past queries and results, not just the exact words, and they can pull information from multiple different knowledge sources, use various tools. Now, setting this up might be more complex, maybe even cost a bit more per query initially compared to simpler Erge, but the payoff is often much higher accuracy, less redundant work over time, and better ability to scale up for really complex information needs. It's that trade-off for overall superior performance.
So scalability is a defining feature, especially with these multi-agent designs. They can grow.
Absolutely. They're built for it. Enables that sort of seamless horizontal scaling that big enterprise applications really need.
Makes sense. And all this planning, learning, collaborating, it falls apart if the system has the memory of a goldfish, right? Enhanced memory management seems critical.
Oh, absolutely essential. Persistent memory is huge. It's what lets the system maintain context across long conversations or tasks that take multiple sessions. It remembers past choices, maybe your preferences, intermediate results from a calculation, so it can pick things up where you left off, build knowledge over time, makes the interaction feel coherent, not like starting fresh every single time. And this memory directly feeds into better planning and execution.
And beyond just remembering the conversation, There's caching and external knowledge.
Right. Techniques like semantic caching, which we touched on with agentic OAja, remembering the intent helps retrieve relevant info faster, more accurately, and the ability to connect to and integrate information from multiple diverse external sources, databases, APIs, live data feeds, using different tools that vastly expands the agent's world knowledge and capabilities.
So it's not locked into just one knowledge base.
Exactly. This makes it more flexible, more adaptable, and critically helps improve factual accuracy and reduce those hallucinations where the AI just makes stuff up. Gives it a broader perception and action space.
It really feels like everything is interconnected. The architecture enables the memory, which fuels the planning. And speaking of architecture, the source mentions the underlying structure itself makes a difference.
It definitely does. The analysis briefly touches on different patterns, vertical, horizontal, hybrid architectures like IBM talks about, how you actually structure the system, how the agents connect and talk to each other. That choice has a big impact on performance, scalability, how well coordination works.
And there are specific tools, frameworks to help build these. The source listed a few, like LangGraph, Crew AI.
Yeah, exactly. Frameworks are crucial. LangGraph uses graphs to map out agent workflows. Crew AI is focused on making it easier to build these collaborative crews of agents. Swarm is another one, more minimalist. These frameworks provide the plumbing, the scaffolding. They offer ready-made ways for agents to communicate, share data, manage tasks, coordinate their actions.
They handle the tricky coordination part.
Yeah. They provide the mechanisms for it. Yeah.
Yeah.
Because without solid coordination, a multi-agent system would just be chaos, right? Agents tripping over each other. These frameworks help ensure agents work together effectively, share information, align their efforts, resolve conflicts. They really streamline development and are pretty fundamental to achieving the kind of scalable, efficient performance we're calling superior.
Okay, we've covered a lot of ground on what makes these systems potentially superior: planning, learning, memory, architecture, coordination. But how do we actually know? How do we measure this superiority? What are the metrics, the benchmarks?
That's a critical question. Evaluation needs to be rigorous. You need good data sets, realistic simulations. We look at standard key performance indicators, KPIs like accuracy, efficiency, how much resource it uses, latency, how fast it responds, and adaptability, of course. For specific tasks like generating text, you'd measure things like coherence, relevance, factual correctness. For prediction tasks, it's often precision, recall, F1 score, balancing different kinds of errors, and superior performance. It's usually not about maxing out just one metric. It's a balancing act, optimizing across several goals at once.
So technical metrics. But what about the human side? Especially if we're interacting with these things.
Great point. Human-centered criteria are vital. User satisfaction. Conversational flow, does it feel natural to talk to? These measure the quality of the interaction, build trust, relate to explainability. How well does the AI align with what humans expect and need? Hugely important for collaborative AI.
And security, with more autonomy.
Oh, yeah. Robustness to adversarial inputs and security benchmarks are non-negotiable, especially for high-stakes applications. More autonomy means potentially more risk if things go wrong. So systems need resilience against attacks, safety mechanisms, checks for bias, data privacy protection, clear accountability. That has to be part of the evaluation.
And the source mentioned benchmarks, specific tests.
Right. And importantly, moving beyond just English or general knowledge, we need multilingual benchmarks like MAPS and domain-specific ones. Tests like GAA for real-world tasks, SWE bench for coding, math for reasoning, and evaluations tailored to medicine, finance, whatever the application is. Because performance isn't uniform across domains.
Evaluating all this sounds like a massive job.
It can be, which is why automated evaluation is gaining traction. Using one AI, like an LLM, as a judge to assess another AI's performance based on set criteria.
An AI judging an AI.
Yeah. It helps speed up testing and iteration during development, but, you have to be careful about the quality and potential biases of the judge AI itself. It's a tool, not a perfect solution.
Okay, so let's make this concrete. We have the pillars, the ways to measure. Where are we actually seeing this kind of superior agentic AI making a difference in the real world? The source had examples, right?
It did, across several sectors. In finance, think automated trading systems that react faster than humans, sophisticated risk management models, or fraud detection that spots complex, evolving patterns. JP Morgan Chase, Bridgewater, Silent 8. Companies using this tech to analyze massive data streams, augment their analysts, sometimes take autonomous action.
Okay, finance. What else?
Healthcare is another big one, moving towards precision diagnostics, using AI to analyze scans or patient data with incredible detail. managing chronic diseases with personalized, adaptive plans, assisting surgeons in robotic surgery for greater precision. It's about high-precision analysis, learning from experts, adapting in real time.
And robotics. Seems like a natural fit.
Absolutely. Autonomous navigation for self-driving vehicles, obviously, but also advanced warehouse automation robots, optimizing inventory, picking items, managing space dynamically, and manufacturing, using AI for simulations, optimizing designs, even suggesting process improvements discovered through learning. Adaptive physical autonomy is the key there.
Supply chains, too, right? That seems complex.
Hugely complex and ripe for this. Agentic AI can continuously learn from sales data, weather patterns, news, everything to make better demand forecasts, optimize logistics, finding the best routes dynamically, even manage supplier relationships by assessing risk or performance. It really shifts supply chain management from being reactive, fixing problems after they happen, to being proactive and predictive.
And smart cities.
Yeah, leveraging all the data from IoT sensors, optimizing traffic signals in real time, managing energy distribution efficiently, and crucially, emergency response, analyzing live feeds, coordinating police, fire, medical resources much faster and more intelligently during incidents. It's system-level thinking to improve urban life.
It's really powerful to hear those examples. You can see how those abstract concepts, multi-agent systems, dynamic learning, planning, translate directly into solving really significant, complex problems.
Exactly. It shows this isn't just theory, it's delivering tangible value, enabling things that just weren't feasible before.
But with all this power and autonomy, we have to talk about the ethics, the responsibility side of things. Technical superiority isn't the whole picture.
Absolutely not. And the source rightly emphasizes this. There are major challenges. Algorithmic bias creeping in from data. Lack of transparency, these systems can be black boxes, hard to understand why they made a decision. Accountability gaps, who's responsible if an autonomous system makes a mistake. And huge concerns around data privacy and security, especially with sensitive information or potential adversarial attacks. If these ethical issues aren't addressed proactively, they completely undermine any technical brilliance. Superior AI must have ethics baked in from the start.
So how do you bake it in? What are the solutions?
A key one is the imperative of human oversight. We talk about human in the loop, or HITL. It's about finding the right balance between autonomy and human intervention, defining clear boundaries, having humans step in at critical decision points, continuous monitoring, audit trails.
So not full automation everywhere.
Not necessarily. It's often about human agent augmentation. The AI assists the human, provides insights, recommends actions, making the human more effective, not just replacing them. HITL is crucial for building trust, ensuring safety, and frankly, often achieves better overall performance through collaboration.
Okay, human oversight. What else?
Establishing robust governance frameworks is essential. Clear policies, defined roles and responsibilities specifically for overseeing these agentic systems. Managing risks systematically. This means having the right infrastructure, things like data anonymization, access control, strong authentication, and rigorous testing and ongoing monitoring, specifically looking for ethical issues, bias, security vulnerabilities, AI red teaming, for instance. Good governance isn't just a compliance checkbox, it's a strategic asset. It enables safe deployment at scale, builds trust, and allows for continuous improvement.
So it's a whole ecosystem of technology, process, and human judgment.
Precisely.
Okay, well, this has been an incredibly insightful deep dive. To sort of wrap things up, it sounds like superiority in agentic AI isn't about one single feature, is it?
Not at all. It's really a sophisticated interplay of many factors, as the analysis showed. You need those advanced planning and reasoning capabilities, often hybrid approaches. You need dynamic, continuous learning and adaptability. Robust, often multi-agent architectures are key for scalability and resilience. Intelligent, persistent memory management is crucial for context and coherence. And all of that technical capability must be built on a foundation of responsible AI design, strong governance, and meaningful human oversight. True excellence, the kind that will have lasting impact and gain broad adoption, comes from this holistic approach to systems that are not only intelligent and capable, but also reliable, adaptable, and fundamentally trustworthy.
A fantastic summary, and thank you sincerely for providing the source material that really fueled this whole exploration. It was incredibly rich. We really hope this deep dive gave you, our listener, some clear takeaways, maybe a few aha moments as you think about this incredibly fast-moving field. Definitely keep exploring agentic AI.
And maybe one final thought to leave you with, building on everything we've discussed from the source. Given the increasing autonomy and the interconnectedness of these agentic AI systems, What new kinds of human skills and expertise do you think will become most critical, not just for building these systems, but for effectively collaborating with them, and maybe even more importantly, governing them in our complex, real-world environments? Something to ponder.
Definitely something to ponder. Thanks again. We'll see you in the next deep dive.